Good morning. This is Anuranjani from CSE department and I am going to handle compiler design subject. Today's topic is about semantic analysis. What do you mean by semantic analysis? Whenever we type a program, we may have errors in all our programs, but lexically and syntactically, we never know what are the errors inside the program. So we are going to analyze all the errors through lexically and syntactically to lexical analysis and syntactic analysis. But even though we are using lexical and syntactic analysis to analyze the errors in our program, we may get many errors as such in our programs. So to identify most powerful errors, that is, their lexical and syntactic analysis are not much powerful enough to correct the usage of variables, objects, and functions. So in order to ensure that the program satisfies a set of rules and also identifies these set of errors, we are going to use semantic analysis. So what do you mean by semantic analysis? Means it satisfies a set of rules with regardless of the programming constructs such as variables, objects, expressions, and statements. Next, we are going to see about the examples of semantic rules. Variables must be defined before being used. A variable should not be defined multiple times. So we know that whenever we are going to define a variable, we need to declare the variable first. But whenever we are going to declare the variable first, we'll be having certain set of terms and certain set of expressions to define the variables. In case if not, if a variable is not declared first, then we'll be getting a error. That is what is mentioned in the semantic rules. Same way, in an assignment statement, the variable and expression must have the same type. As I said, we'll be having number of expressions and variables and characters inside our programs. So each of these things will be having some types regardless, some same types regardless of the nature of the functions. So semantic rules will be applicable to identify the errors and also spot the rules according to the semantic analysis. So the test expression of an if statement must have a Boolean type. That is an example of a semantic rule. If you are going to use if statement or do while statement, etc., we'll be having a Boolean expression type. So same way we'll be having for other semantic rules or other loop also, like for loop and while loop, we'll be having certain set of rules where certain set of expressions alone will be used. So these rules will be followed when a program enters into one semantic analysis and the errors will be given to us, which are not identified by the lexical and the syntactic analysis. Next, typical semantic errors. First one is multiple declarations. Yeah, we will be using variable at multiple places, but the scope of the variable differs. So where variable can be declared outside as well as inside. So this multiple declarations will be considered as one of the error of the semantic analysis. If it does not imply to the semantic rules in the scope. Second one is undeclared variable. We said about this before. If you are not going to declare the variable in your main function, we cannot use that variable further in the procedures. Otherwise, you have to declare it at least in the procedure before giving a value to your variables. So undeclared variable is also one of your semantic errors. Next one is your type mismatch. Type mismatch is every left hand side should be equal to its right hand side. Assignment assigned, that is 1 equal to 0. That like any expression statements should be always equal to be right hand side. That is LHS should be equal to your RHS in your assignment statements. Next one is your wrong arguments. That is methods should be called with the right number and right type of arguments. Whenever you're going to call a statement, whenever you're going to call a argument, or whenever you're going to return a value, each and every type we should return the return type value should be written in an order in the same manner. So the return value, if it's 0, it needs to call 0 only. It should not call 1. So that is one of the semantic errors. Same way, you're going to call any methods. So you're going to, your main function, your main method is going to call your sub method. You have to know that the exact statement calls only the sub method correctly or not. So these type of errors are known as wrong arguments. Now we are going to see about the categories of semantic analysis. So the categories means the semantic rules are segregated into two categories. One is with the scope and other one with the types. So first we are going to see about the scope analysis. Scope analysis characterizes the declaration of identifiers and the portions of the program where it is allowed to use each identifiers. So whenever you are going to have identifiers like variables, functions, or labels or objects inside your program, we need to use it wisely and in the right place in the program. So what the semantic analysis will do, it will identify whether the given variable or the declared variable or the declared function has been used in the right place and position or not. That is what the scope analysis will be doing. Now lexical scope. Lexical scope means your statement block or a method body or a procedure. That is method or nothing but a procedure or a function or the whole program consists of the textual region in the program. That is called as a lexical scope. Scope of an identifier is a declaration. It's mainly about that declaration. So whenever you are going to initialize a variable or initialize a function, or even you're going to declare a function or declare a variable or declare an object, labels or characters, anything, we have to declare it in the right place and right portion of the program. Yes, it will be coming under semantic analysis and it will produce us as a semantic error. So now we are going to see about variable scope. Scope of variables in statement blocks. So for example, there's a code here. That is, you have an open flower basis int A and you have a set of code. And again, you have open flower basis int B. That is, int A is nothing but integer A and int B is nothing but integer B. And A is a variable and B is another variable. So where does the scope of the variable A implies is that from starting flower basis to the ending flower basis will be having the scope of variable A. So next one is int B. From the flower basis where from int B before it has opened, right? From there till the next flower basis, it will be scope of variable B. The scope of the global variables, it's nothing but the current file. And external variables, that like A is the external variables, it is about the whole program. Int B will be coming and that variable will be coming under the current file. And the external variable is nothing but it is a int A, which is the considered as the whole program. Next one is your function parameter. Okay, function parameter and the label scope. So scope of formal arguments of functions. Here they are given it as int FOO. FOO is nothing but your function. In bracket we have int n. N is nothing but your argument. So you are having your argument scope only inside the flower braces which starts from that function and ends within that function. Immediate close braces comes, right. That is where that function ends. So inside that function alone, the int argument will be applicable. Now scope of labels. In this, we have to identify void FOO. It's given as your function. It's a void function. Next, they are given as go to lab. Lab is nothing but your label, scope of label, because lab, they are given it as declaration for the label, and your label has been given like lab colon I plus plus. That is where your label implies. So the scope will be from void function open till void function close, because we have declared our label in the void function itself. First of all, in that FOO function, next statement itself, the label has been declared. So after the label has been declared, the label has been used by the I increment operator. So the scope of label will be inside the particular function alone. So scope of object fields and method. That is in your class declaration, how we are going to say about the scope semantic analysis. Now there is a class A, then they have a open flower basis. Public class. We will be declaring some variables in public and some variables in private in C++. So they are given it as in such a way that public and private. Here they have declared X as the variable and F as your method or function. Okay, the scope of the variable X and the scope of the method F will be inside that particular class alone. Clear? So void F is nothing but your method F and X is equal to 1. They have declared the variable F and they have declared the function F. Now in private they have declared the variable int X. The value of the X is X is equal to 1 is in the public place. So the scope of both the functions and the variables are inside class A. So this is the semantic rules for the scope class. Okay, rule 1 is that use each identifier only within its scope. You have to use identifier only within its scope. See, class X, then they have declared int X, and again the int X is given inside the function as an argument, and the X is given as a label. So whatever you have declared, you have to given within the class X itself. So if your function F is scope is valid till from the open braces after void until the closed braces after the go to, and a variable is declared in between the class itself. So it comes inside the class itself. Next one is that int X. So int X, and in bracket we have the argument X. One X is a function and another X is an argument. And again we have one variable X. Now next we have go to X, and that X is considered as the label. X is equal to 1. Now we need to identify whether these portions are legal or illegal or not, regardless with the semantic rules. So whenever we are going to use the semantic analysis, our main objective is to store the data in the right manner. For storing those data, we will be having a structure, data structure known as symbol table. That is, symbol table is equal to set of entries. We have said about lots of functions, variables, etc. All these functions, variables, methods, objects, classes, everything will be stored inside the symbol table. So the purpose of the symbol table is that we need to keep track of names declared in the program. Second one, the names are whatever I said now, variables, classes, fields, and methods. So the symbol table entry is always associates a name with a set of attributes. So we need to give a kind of name for the class. Each a class has a name, a field has a name, a function has a name. So all these comes under the kind of name. Next comes our integer, float, double, character. Everything comes under that type. Next, we'll be having the next thing level, memory location, etc., etc. So the symbol table entry consists only of the expression given in the front. That is, this comes as an attribute, set of attributes. So this is an example for the symbol table. So semantic checks refers to the properties of the identifiers in the program. So the identifiers should be stored in an environment, and that environment is defined to us as a symbol table. The symbol table always contains the information of the program we are going to use. So now, for example, for an entry in a symbol table always contains the name of an identifier and also the additional info like kind, type, constant, attributes, etc. So I have given a list, set of examples like for name, kind, type, and attributes. FOO is a function. In function, and the type can be a integer, and attributes can be external because it's an external function, so external. Next comes a M. M is an argument, so int. Then at the date it does not contain any attributes at all. Then again N. N is an argument. It does not. It has a constant. So now we have a temporary variable. So temporary variable, kind is a variable, type, what is a character, what is an attribute, constant, because we need to symbolize what kind of attribute it is. It is, if an integer, it's a constant value, means it's a constant value. If you're going to get the value, means it contains another attribute. So according to the type of the identifier, according to its kind, we need to name it and save it in the symbol table. Next is a scope information. How to capture the scope information in the symbol table. So for an idea, one symbol table for each scope will be given. So each symbol table contains symbol declares in that lexical scope. So for a single program, it will be having a single lexical scope, and so that single lexical scope will be having a single symbol table. So this is example of our symbol table, and the side is a example program. Int x is a variable declared first. Next void f is a function, and int m is a argument, and float xy. X and y are again a variables with the definition with the float. So int ij and again int x semicolon l colon. L colon is nothing but a label now. Next again int g is a function, and int n is an argument. Argue t is a variable again. So in the global symbol table, we'll be having see x is a variable, int f is a function as and what, int, and it's a void type. Now next g is a function, again it contains of int, but again it's not an void one, it's an int type. So now we have the function f symbol table and function g symbol table. In function f symbol table, we'll be having the variables like m, x, and y. M is an argument, X is a variable, Y is a variable which is a float. Then we'll be having N and T. N is an argument, T is a variable for the function G. Now again inside the F symbol table, we'll be having I and capital I and small j. And X and L. L is a label. This is how the symbol table will be stored. Next, identifiers with the same name. In the symbol, using this symbol table only, we can identify with the same name. Already we said that semantic rule as a specific rule, like we need to identify the symbols with the similar names or the variables which have been repeated or the same variables, or these are semantic rule errors. So symbol table will be helpful for us to identify us which are with the same name. Okay. So to find which is the declaration of an identifier is to activate at the program point and start from the current scope. Next, this is a class problem. So we have to associate each definition of X with its appropriate symbol table entry. So again, the same one, we have to associate the definition of X alone. So X is equal to 1, X is equal to 2, L, they have labeled it. Then X is equal to 3. How they have associated it, but this comes as an error. If you check, you can check the semantic error in this. So int X void f of int m open braces, then float x comma y, and int ij x is equal to 1 in. So we have already studied about the global symbol table and how they have derived from the global symbol table to the local symbol tables and all. So that is the function f1 and the function g1. In the function g1 and in the function f, we will be having I2 as an error because the I variable is being an undefined variable. Okay, we have given it as int I comma j, but int x comma didn't label again, so that I equal to 2, which is always going to be given as an undefined variable. So semantic error is that we'll be having the same names as the error, and also undefined variable also is one of the semantic error. So symbol table operation. Symbol table operation, that is two operations we need to have in the symbol table. To build the symbol table, we'll be using the insert operation. That is, we need to insert the identifiers of a program inside the symbol table. Then when the stages of the compiler takes places, we use a lookup function to look up at whether the identifiers or variables have been repeated again, or whether they have been defined or not, whether they have been declared or not, will be defined from the symbol table. So in order to that, we have to build the symbol tables using the using the details which we have been derived from the lexical analysis and the parsing, and then with the sympactic actions, we'll be having the AST constructed, that is abstract syntax tree constructed, and from the abstract syntax tree only we'll be developing our symbol table. Next is forward reference. Forward use of an identifier within the scope of its declaration, but before it is declared, we need to identify the scope of the declared identifier even before it is declared. So any compiler phase that uses the information from the symbol table must be performed after the table is constructed. That is known as a forward references. Type information. Now we studied about the scope and the types, like two categories. So we have now, from the scope we have moved on to types. So we need to know what are the types. They describe the values computed during the execution of the program. That is known as the type. So in text, in C language means -2 to the power 31 is lesser than or equal to x lesser than or equal to these what will be executed during the program while we compile the program. So the type information is that it describes what kind of values corresponding to different concepts. Mainly we'll be concentrating in the semantic analysis, right? Variables, statements, expressions, functions, method, procedures, etc. So in variables, if it's int a, it is an integer. If it's going to be an expression a plus 1 equal to means that is a Boolean expression. Okay, then if we are going to use a statement, that is, we are going to declare the value of for an identifier in the same place itself. That is a equal to 1, a equal to 2 means it consists of any integer value or a double value like that. A equal to 1.0 means since it's a decimal one, we are going to give it as floating point value. Then functions, that is like int FOO, we saw it previously. Same way like int POW, that is int n, int m, int, that is equal to int comma in. This is the kind of function. So what kind of function it is, that we have to give in the type information. Next one is type checking. Type checking are nothing but type errors, improper or inconsistent operation during program execution. That is, it is an inconsistent operation during the program execution. That is what typo errors are. Type safety. Absence of the type errors is known as type safety. So to do these two, we'll be having type checking. So a set of rules which ensures the type consistency of the different constructs in the program. We'll be having a set of rules. In those set of rules, we need to ensure that the consistency of the typing has been made or not. So with the consistency, we'll be ensuring the safety of the program and also the errors in the program with the different constructs in the program. So this is what known as type checking. So semantic checks to enforce the type safety of the program. So examples, unary and binary operators. Unary operators and binary, unary is plus, binary are equal to, then we will be having or value, not value, and value. All these things are called as the operand or the proper type. Functions must be invoked with the right number and the type of arguments. For example, int m, in braces will be having int n. So that is called as m is a function, and in the bracket will be having n as the argument. So the function the function must invoke the right number or the right variable which has been declared in the argument. If it's going to invoke a wrong variable, then it is a type checking one, because we have given the we have given wrong variable in the another place due to type checking. Next, return statements. Return statements must agree with the return type. Return 0 means it's return 0. Return 1, then it's return 1. But for instance, for example, for return 0, if it's going to call for return 1, then it is an error of type. So for return 1, if it's going to call return 0, then it's you would have given only return 0 in the program. But inside your program, there is a typo error where your value is written to 0. So we need to return the statements which agree with the return type return type alone. So such statements to be identified or given correctly in the program. Next, in assignments, assigned value must be compatible with the type of variable on LHS. So type of variable with the, that is what we said. RHS is always equal to B, LHS for the assignments. A equal to 1, B equal to 2. So A value, if you are getting it 1, it should be equal to 1. The assignment should be equal to 1. So if it's B value equal to 2, the got value B in the program should be equal to 2. So these are known as the assignment statements. Then the class member assessed properly. So the class members are assessed properly. Means inside a class you'll be having n number of members or the n number of variables which are used in a particular program. So for this particular program, we have to assess the members properly. That is, call them, invoke them, and also declare them, initialize them properly inside the program. So all these things comes under type checking. How to ensure your type safety? For that, we'll be having type binding and type checking. So type binding means defines type of constructs in the program. Example, variables, functions. They can be either explicit or implicit. Explicit means in X alone. If implicit means you have declared the number for that variable or an integer for the variable in the specific place itself. This is known as the type binding. Type checking, it consists of the set of type checking rules which we have seen it already earlier. That is known as type checking. That is, you have to determine if the program correctly uses the type bindings or not. So it defines the type of constructs in the program and in the variables and in the functions. We have 4 concepts related to types, languages. Static versus dynamic checking means we have to check types. Static versus dynamic typing is to define the types. Strong versus weak is how many type errors are there. Sound type systems is statically we have to catch the type errors. Statically we have to catch the type errors. Static versus dynamic checking. Static checking is done when the compile time. Dynamic checking is done in the runtime, that is program execution time. Examples of dynamic checking are array bounds checking and null pointer differences. All the errors are not done in the execution time. Most of the errors will be done only during the compile time. That is called as static type checking. That is what we saw it before, like scope and variables, etc. Dynamic checking means that was the certain variables or certain declarations will be identified only during the program execution time. So that's like examples are array bound checking and null pointer differences. So as I said, static will be in compile time and dynamic will be in the runtime, that is program execution time. Now, strong versus weak typing refer to how much type consistency is enforced. Strongly typed languages means it's always type safe, guaranteed accepted programs, but weakly typed languages are always prone to errors. So these concepts refers to always runtime. That is the execution time. They can achieve strong typing using either static or dynamic typing. So, as we saw, the strong versus static. That means static versus dynamic. Static are in the compile time and the dynamic is in the runtime or in the execution time. Certain errors of type checking will be calculated during the compile time and certain type check errors will be calculated only during the dynamic time. That is known as the runtime time or the program execution time. So now we'll be saying about a strong versus weak typing. So the weak typing means it is a guaranteed accepted program or type safe. That is the strongly typed languages, which we cannot defeat those languages and we cannot get errors in that language. So it is considered as type safe. Whereas weakly typed languages will allow programs which contain type errors, which contain the type errors. So these two concepts are always referred to as in the runtime. Can achieve strong typing using the either static or dynamic typing. So why static checking? Efficient code. Why we are doing static checking? Because Efficient code means dynamic slows down the process if you are going to check the code line by line during the execution time. Second one, guarantees that all the executions will be safe. Yes, if you are going to compile your program in the compile time itself, check the errors in the compile time itself, we'll be having a very execution safe programs during the run time. So that's why most of the errors are used, most of the errors are identified in the static time checking itself. But it is conservative for sound systems. That is, need to be expressive. Reject few type safe programs. These are the main advantages for the efficient static time checking. These are the main why we are going to do static checking means efficient code, because dynamic check slows down the program, guarantees that all executions will be safe, and also conservative for the sound systems. Next is the type systems. What are the types? They describe the values computed during the execution of the program. So whenever we have a variable or an integer or a character, anything is defined, all the values given to each particular identifier will be described during the execution time. So we will be having type expressions, that is int, character, array, object, etc. These are the possible types in the program. The type systems means they are expressions and statements. Expressions are nothing but if, else, do, while, all these. And statements means we will be declaring A equal to 1, int B equal to 2, int array of 1, 2, 3. These are known as the statements. But the expressions are nothing but we will be declaring it in the space. Type system means we'll be having expressions and also we'll be having statements. These are known as the type system. That is, they describe the values computed during the execution of the program. Essentially, they are predicate on values, and they, for example, it is given as int x in C means. Same way, these are the example we saw for type checking too. That is a type errors too. So we'll be having a types expression where the possible types in the program will be given as int, character star, array, object. So these are the expressions. That is, the declared ones as a variable, functions, or anything will be given inside the type expressions. And for type system, it will be defining the language constructs. That is, the expressions and the statements that are used inside the program always comes under the they always comes under the type systems, so which defines the types of language context and also the expressions and the statements. Next is the type expressions. Type expressions are nothing but language type systems are basic types, and build type expressions means using basic types. Type constructors, array type, structure, pointer types, types, aliases, and function types. These are certain type expressions used in the program, which will be coming under, which is the criteria where the semantic analysis will check for errors in these types of expressions. And two variations of semantics have been given, that is a static and semantics and the dynamic semantics. That is, after the analysis of these things, then we'll be moving on to the variations of the semantic itself. When the static semantics are attribute gammas, in the dynamic semantics are operational semantics, axiotic semantics, and denominational semantics. This is the next step in the semantic analysis. Thank you.